Transformer models. So what are they? So like one of the breakthrough in the current industry of ChatGPT or this Google Bard and all this, like whichever we are using all these years. So like it is all because of one major breakthrough in architecture in language models, which we call it as transformer models. There is a research paper published in 2017, so which we are calling it as attention is all you need. So now we already learned about attention mechanism or attention based models in our previous example, like we learned about attention based models. Now whenever you are getting into this transformers, it is something similar but more complicated than your regular what is that attention based models. So this is one of the fabulous architecture. So with respect to this fabulous architecture, like all these companies, let's say like Google people came with it, or Hugging Face people came up with another one, and even the ChatGPT, the OpenAI people came up with ChatGPT, where we all using ChatGPT 1, 2, 3, now currently even 4. So now all these breakthrough results we are able to see only like with the help of transformer models. If there is no transformer mechanism, I don't think so. Like there is such kind of wonderful output, or we are able to enjoy all this language thing in such a great extent. Now let's go deep into this transformer models. So whenever we go to the transformer models, like here, see this. This is one of the image which I collected it from Google AI blog. Now, let me give a small difference between your regular what I can say on your regular attention-based models and your what is that transformer models is. So in our attention-based models, there is a problem. So that is called as it is lacking the self-attention. What does it mean by a self-attention? So now this attention-based mechanism is able to collect the encoder data, and we are able to take even one decoder data. It is able to multiply, and we are able to feed it to your softmax, and we are able to get a particular attention output. We are able to get it. So now here, if you notice it, this particular, for example, there is a word, hi, how are you? Or you are able to see, I arrived at thee. For example, there is a word like, I arrived at thee. So now here, we are translating that into something else. So in order to go with I arrived at thee, if you see this, so now each word is interacting with another word, or each token is interacting with another token in order to understand about itself. So now it is arrived is trying to understand about itself, so by understanding with other tokens. So that's what happening in the self-attention mechanism. It is not just working towards one word, or we are collecting all the different tokens and we are not feeding into the decoder, so like your encoder technique or the attention based models, but each word is trying to understand about itself better by comparing with other words. So that gives us more clarity about the context. So the transformer models are able to understand the context in a better way. So whenever it is able to understand the context in a better way, it is able to translate the things, or it is able to auto-complete the things in a wonderful way. That is the difference. So now this particular encoding technique, so it is trying to understand each word with other words, and based on that, again, if you notice, see this. So now in order to decode it, it is trying to understand it with other words, and it is taking the help of even decoded words, and it is trying to make the another decoding classification, or it is trying to make a decoding, or it is able to make that prediction. How it is comparing the other words of encoding as well as the decoding of other decoded things, and it is making a class. That's how your transformer models are working. So in order to achieve this, there is an architecture. So now this is a very big architecture where your transformer models are running through. So now here you got your positional encoding. The purpose of positional encoding, in a very simple note, like whatever the text data you have it, you want to convert it, or we want to translate that into one of the encoded representation, or into the alphabetical representation, into the numerical. In order to do that, all the input data is fed into input encoding. So we are able to get the positional encoding of everything. And after that, this is called encoding layer. This is called decoding layer in a transformer. So in an encoding layer, you have a multi-head attention, and you have add and norm, or we can say layer normalization. So we got feed-forward neural network, and again another layer normalization. that information is fed to your decoder. In the decoder, we have masked multi-head attention, and you have again a feed forward and layer normalization. So in a very simple note, in order to understand transformers, we majorly need to understand overall three concepts. First one, we need to understand about scaled dot product. So that is very important. And we need to understand from the scaled dot product, you are able to get self-attention. So once we came to know about self-attention, then we need to understand about multi-head attention. And after that, we need to understand about masked multi-head attention, or we can say masked multi-head attention. And the next one, we need to understand about layer normalization. If you are able to understand this, yes, you are able to understand about your transformer model. So within this transformer models, this transformer architecture is used by GPT, it is used by BERT, it is used by for example, all the different models which came into the picture, all the models are trying to use this particular transformer architecture. So they're increasing the layers of encoding and the decoding. So the intelligence of your models is going to increase. So now what is meant by this self-attention, or what is meant by this mass multi-head attention? What is this mass multi-head attention? Let's try to dig deeper into those topics. In a simple understanding, let's understand. So intuitively, transformer encoders can be thought of as a sequence of reasoning steps. At each step, tokens look at each other. So now each word is looking at each other. So this is very important. So tokens look at each other. This is where we need attention. So that attention is called as self-attention. So why it is doing? So by looking at other words, it is able to understand about itself in a better way. What is the purpose of me? What is the context of me? It is able to understand about itself in a better way. Exchange information and try to understand each other better in the context of the whole sentence. That's what I said. This happens at several layers. So this is happening not at one layer, but it is happening at several layers. So it is able to understand about itself in a better way. If it is happening only at one layer, we call it as self-attention. If it is happening at multiple layers, we can say multi-head attention. So let's dig deeper into that in a simple note. Now, before we are getting deep into the transformers, so as I said, there are three layers which we need to understand. Like as I said, so one, we can say self-attention, next multi-head, masked multi-head, and next we need to know about layer normalization. So before we are jumping into it, see you on the next.